We're here in my birthplace, the home of my ancestors, and we are going to hear people's theories. So this is a show where if you have an idea about how something works in the world, you get a chance to present it. 30 people have signed up for the chance to present their ideas tonight. And let's see what the hands of fate have in store. So,
Go ahead.
If you're gonna maybe pull out our first guest, we'll announce who the first hat draw is gonna be, and the first person we have on deck, we have
to explain to the good people how this game works and the rewards that are inherent in presenting the world's best theory. So basically, if anybody's new here, the way that this works is that everybody who gets pulled out of our excellent top hat of fortune is given 60 seconds to present a theory of how nature works. Afterwards, our esteemed panelists, musicians, and friends, and me and Shiloh will interview you about your theory. At about 60 seconds, if you haven't wrapped up your theory, you probably get a little bit of grace, but very, very quickly, you are going to hear the sound of a gong. And that means that your 60 seconds are up, so wrap up your idea, and then we can move on to the next phase. I'm going to pull a name out of the hat right now, and this is going to be the person who is on deck. And so who do we have on deck? Matthew Fox, everybody! Matthew Fox. And so before Matthew Fox is on deck, we have our first regular of the night. And so something that people have been telling us is that you can't really have a game show without there being a prize. And so the prize that we have settled on is that if you do an excellent job of presenting a theory, then you get entered into our pool of regulars. And so you get invited back.
First regular was going to be Keelan tonight. Is Keelan here? Keelan, where you at, Keelan?
Keelan's not here yet. Uh-oh.
Keelan.
Bad news.
That's terrible.
All right. Well, we got Ricky in here.
Ricky? All right, let's get Ricky up here.
All right, Ricky, ready?
Cisco, are you ready to go, my friend? Let's play him on with a little bit of serenading music, eh?
Well, hello, Ricky. All right.
On 3. 1, 2, 3. Hit me!
Okay. Last time I explored just the idea that the digital acceleration of ideas and mimetic propagation is going to cause a lot of archetypal possession, weird behavioral patterns that we need to analyze very quickly to come up with solutions. So, now that we have AI, I propose that we are able to scrub data analytics across all in digital domains and start to predict things like Young did in 1936 when he predicted the Germans were going to have some Wotan figure and things are going to happen. Nowadays, when we start seeing phrases repeated all the time, when we start seeing symbolic and cultural motifs getting proliferated, and we can actually create a logic, a system to pretty much mathematize and use AI to come up with pattern recognition and predictions. So if we start seeing political leaders rise, we start to see, so for instance, when all the males died in World War I and II, there was a vacuum. Who filled that vacuum? Women. All the men are dead. How do you predict what happens in that? And we have the devouring mother complex. Go ahead.
Ricky, welcome, man. How you doing? Thanks for coming back.
Good.
Ricky, so you're trying to make some sort of like a weather prediction system for archetypes that will help us guide our society into the future.
Or at least provide debate and to provide context and data. Because what happens is we finally have the systems to do large amounts of data retrieval in a somewhat tangible way using memetics, words, linguistics. That's huge. I mean, think about art. Think about the brutalist art. Imagine you're taking that data and you're going, oh, the society is developing a prison culture. I mean, just to make it simple, but you see these patterns forming. And I think we have enough data and we have enough processing power to actually start laying a sort of a formalized system to computate and at least provide some analysis to go on.
So do you think that what this is doing, or this mode, is like trying to map out where we're going? Like, is it a future prediction tool? So like give the 10,000-foot view for somebody who's never heard you talk about archetypes before.
Okay, so archetypes is, okay, so Hansel and Gretel. Everyone's sort of heard a Jordan Peterson lecture where you take a weird story that is odd, and then you realize that there's this onion of knowledge in it, right? So Hansel and Gretel probably came from a village that had war, all the males died, all the mothers took over with no male presence, and you had children being lured, so to speak, and you get a devouring mother complex.
There's a balance of these different archetypical presences that need to be appearing in a society for it to be stable and healthy.
It seems that way. And that's sort of what we have to do. Is a lot of the people who followed Young, especially Young, did very good jobs at predicting how the Western countries would develop. And a lot of that was intuitive, and how good you were at just as an intuitive person studying the culture and those predictions. Now, I think we can actually provide a formal logic. And this is the next wave of coming, because Jordan Peterson sort of revived a lot of the mythic Jungian Joseph Campbell stuff. He did such a good job bringing that back to life. And, in a way, he was very archetypal. And I think archetypal possession are particularly nefarious in the digital culture because of how fast memetic proliferation can happen, especially with, the way societies can get into weird phases where people are bored and there's energy that needs to get expelled, and where do we go? And a lot of people are trying to create these sort of micro cults, especially for males nowadays, like, Andrew Tate, where cults used to be religious and maybe like more moral, but now cults are going to be more about augmenting you as making money, augmenting you as being smarter, physical. We're moving into this weird, we're trying to attach ourselves to something, and I think we have to start figuring this out quickly before things get weird.
Chris, do you follow this at all?
I mean, I think I kind of understand what he's on about. Yes.
Well, it's basically there's a shape that everybody falls into,
like a mold or a model that we all try to identify with and go with.
Yeah, and that, like, in times of great destruction, men especially, though I think that this is probably true for women especially, fall into these weird traps where the molds aren't good, and so they end up derailing the entire civilization into these dark places. So I guess the question is, like, does this hold true? Like, do you feel yourself pulled by molds?
Is that kind of like one of the strong men make weak men make, etc. models?
Definitely related to that. Definitely related to the cycles. A lot of, an archetypal is really just a behavioral pattern, and that's cyclic, that is based in nature. So Anthony Stevens, which everyone should look up, took Jung's ideas and applied them to biology. And biology, I think governs our minds to a great deal. And so, like you said, if you lose a big male population, there's a vacuum, and archetypes help predict how that vacuum will be filled. And then if you're watching it in real time, and suddenly, let's say you have all the women fill these voids that men left, and then so they're taking over a lot of work. They're starting to take over, the occupations.
We were talking about earlier on the porch, Chris, with you were talking about gender roles being all whacked up since the industrial age, even really since the 1950s when women returned to the workplace, and how it's thrown people off balance. They don't know how to date. They don't know how to hold households. Like,
yeah, we just did this.
Yeah. So there's a yo-yo effect, and it's and so if you're wise to this in that time, and let's say you go, oh, okay, so we just had like 20 million males just die. That's huge, and we don't think that, oh my God, this is gonna ripple through society, because something has to fill that. And there's a lot of fathers that are missing. It's a lot of industrial force that's missing, and then women take on that role, but they're just living their own isolated lives, not seeing how they are part of a bigger whole. And so what happens is the devouring mother complex is when the balance tips so far that the women start identifying in masculine archetypes because they had to fill that role. And they're not suited for those. And so what happens is the maternal instincts get married to masculine archetypes, and then suddenly you have a devouring mother. You have a police state. You have anytime the maternal instincts get projected in places that it's not meant for, you get communism. You get that sort of like infantile, the delayed of growing up, the nanny state.
Ricky, I think we gotta keep moving this thing. What I would love for you to do, man, when you come back next time, is bring another example, like not just the masculine, feminine, but if we could come at this from some 2 other archetypes or 3 other archetypes, I would love to see that.
Next time, I might be able to actually give you a data presentation using some new tools, and I wasn't ready this time, but maybe next time. But hopefully you had fun. Thank you guys, I appreciate it.
All right, guys, give Ricky Cisco a big round of applause.
See you next.
Thank you.
Excellent. So we've got Matthew Fox in the room, and then we've got Lyndon Ashmore on deck. Is Lyndon Ashmore? He is, or she is. Excellent.
Lyndon Ashmore on deck.
All right. Matthew, welcome back.
Let's count Matthew in here. Let's give him actually, did we give Matthew a round of applause, guys?
All right.
Come on, guys. Let's welcome Matthew back. Matthew Fox, one of our dear friends and patients.
There's fewer equations on the board than last time. This bodes well. All right.
Let's count them on 3. 1, 2, 3. Hit me.
All right, guys. The vacuum energy, lambda, the cosmological constant. It has been said by some people to be one of the greatest mispredictions, if it actually was a prediction, in all of physics. 122 magnitudes off. Why is this? You take the Planck energy, an elementary unit of energy, you divide it by the Planck length cubed, and you're going to get the Planck pressure, which is a ginormous, 113 pascals. But the vacuum energy is actually 10 to the minus 10. What the heck is going on here? So let's see if we can draw a little intuition here. What would we need to make this actually work? Well, we get the Planck energy, and if you actually do a little trick, you find that the inverse of it, 1 over it, gets you to the first significant digit and magnitude. That's cool, but we're in the wrong dimensions. So let's just do the naive thing and see what it would take to make it work. We're going to need the unit of energy, the joule here, but we're going to need to square it. So we got 1 joule squared. That will give us very close there, but we're still in the wrong dimensions. We still need to add in a volume element. So let's just use the 1 of length, the meter cubed. This gets us really dang close, but we're still off by just a hair. And then at one point I heard Dr. Sabina Hossenfelder say the vacuum energy is just the curvature of free space. Curvature! Is there something we know that has to do with curvature? We just turned that 1 into a pi, but not quite. We actually need something else. Let's actually move this pi outside the bracket before I get gonged. We get the pi, And then we live in 3 spatial dimensions, so 3. And then this surprisingly has extraordinarily good agreement with the current measured vacuum expectations, or at least the Planck 2015. Once you start having the others, it goes off a bit.
All right, Matthew Fox.
Yeah, Matthew.
I was optimistic when we started with so few equations on the board, but
No, I can bring it together because, to be fair, I've only presented a dinosaur right now. We still haven't formed the Megazord. Shall we form the Megazord? It only requires one additional equation.
We gotta back this up a little bit. The cosmological constant is this goop that Einstein shoves into his field equations to make them align with the universe. Is that a layman's approach to this situation? Is that fair?
It's basically in Einstein's mind at the time, to my knowledge, is he believed that we had a static universe because that's basically what most people thought of at the time. So he included a particular term that could actually be fudged in different ways to help make the universe as we know it static. And then we had additional observations from the Hubble telescope and everything. It's like, it looks like it's accelerating. So he's like, I goofed. This is my biggest blunder of my life, something like that.
So the universe, we're told in the standard lambda CDM, the standard Big Bang narrative, the universe is expanding. And Einstein didn't like that.
That seems like a good approximation to it. So we incorporated this term. We didn't think it would actually matter, and then fast forward to I think about 1998, 1999. It's like, it actually looks like it is expanding at an accelerating rate, which seemed very weird. And now we're getting, with the James Webb, we're getting additional data. So maybe it was stronger in the past. Maybe it's weakening. That's one of the reasons it's cosmological constant.
And so you're trying to say, hey, maybe this term that Einstein needed actually says something interesting about what's happening in the universe to do with the vacuum energy, something that's happening in between the atoms.
Well, the vacuum energy itself, it's basically, that's what we get from measurements. So this happens to replicate the observed measurements pretty well. Some folks can disagree with it. That's fine. And then all you do is you literally multiply it by the Einstein-Kappa term over here, which is that 8 pi Newtonian gravitational constant over the speed of light to the 4th power there. Now you look at that, and I know you guys have interviewed Dr. Salvatore Pais on the channel, and he had actually brought this up, and I tried his method, because that's literally just the Planck force with an 8 pi on it. That's literally, because he said that. I know Rick gave a presentation here. He used the 8 pi. Dr. Salvatore Pais is a little hesitant. But when you put that in, the interesting thing is you can redo this a little bit. So this all ends up just going to, because it's 8 pi and we got a pi there, it just ends up being 8 pi squared over 3. And then that's the Planck force. So we just combine it with all that. So that's times the elementary unit, the reference 1 of energy, the joule squared, times, I'm just going to write down energy E sub P for the Planck energy, times F sub P for the Planck force, meters cubed. And we get very high agreement with what's currently out there. Again, if you include the higher distance supernova things, at 76 kilometers per megaparsec. There.
So what is it?
What does this mean? What's the frame
I did this
that
for
I'm
a
hanging
reason.
this on?
I'll break it down.
All right.
You see all this jazz here. This is a numerical factor. Okay. That's geometry there. Okay. So we have energy squared. What the heck is this dang term? Okay. The reason why is I had no idea what this dang term was until I took the square root of it. This actually comes out to be energy squared over bending stiffness squared.
So you're talking about the stiffness of the vacuum medium.
Oh, so you think that it has a physical characteristic?
I think that's what we're dancing around.
Okay.
So it may lead to, again, the interesting thing is if you just take this number and you take the square root of it, you conspicuously get about the radius of our observable universe. So this whole thing, perhaps it's just an illusion to our measurement here. So maybe that's an option.
I'm always suspicious of measurements that end up confirming some observation that we've made, or they neatly divide into something that we've already concluded about the universe, where it makes me feel like there's a little bit of circular definition happening, where it's like one thing happens, hangs on another, hangs on another, hangs on another. Look, I want you to come back, and I want you to give me something that has more handles on it. Like, this is too deep. I want to see a theory about, like, what studying these mathematics gives us. Does that feel fair as a starting point? Because I feel like there's a whole world.
I think you've stumbled upon some sort of patterns that are actually probably quite profound. But I think that we should really focus next time on the significance of what understanding the stiffness of space-time means for us in terms of our future.
I got excited. I thought this was a cool thing. There's a number of other things, and I think one of the things we need to stress is the unreasonable effectiveness of SI. That's probably the core that would have built up better to this to give us more of a framework. So, cool. Great suggestion.
Yeah, by unit, you mean SI like units. Is that what you mean? Yeah. Yes. All right, Chris, did we lose you completely?
It's a little bit above my pay grade in theories, yes. So I would say yes. I mean, I want to keep up desperately, but
this is actually a great opportunity, because I'm like, I think that what we aim for when we're building these theories is we want to make it so that people who understand things at a deep level can talk to people who don't understand them yet. And so it is, on one level, an opportunity to present some theory of how nature works, but I think that it's also a measure of, like, how well can we take each other along for the ride?
Totally agree. It all boils down, in my opinion, to just stuff doing things. What the particular stuff and things we're talking about it may vary in complexity.
And that's the final frontier, as far as I can tell. It's pulling these patterns out and then assigning physical relevance to them. And so let's keep working on it, man. I think we should just tear apart one of these ideas. You know, we do this every month, dude. I'd love to have you come back and develop this one step further. But yeah, man, thank you, Matthew. I love seeing you, dude. It's always good to see you. Guys, give Matthew a hand. What the heck? Come on. Where's our come on. All
right, so we've got Lyndon coming in. Lyndon.
All right, welcome, Lyndon.
Welcome, Lyndon. We got Eugene Yashkin on board for after Lyndon.
Eugene, you're on deck.
And so, Lyndon, I'm going to start your timer in 3, 2, 1, go.
All right, hit it.
Right, Newtonian light, NTL, explain redshifts and other phenomena in the static universe. IgM's treated as a transparent medium, and on their journey to Earth, photons are absorbed by electrons in the IgM, which oscillate and then emit a new photon. The electrons recoil on absorption and re-emission, and some of the energy of the photon is transferred to the recoiling electron. The energy of the photons reduced, frequency reduced, and the wavelength increased. It's been redshifted. Hubble law becomes photons from a galaxy twice as far away undergo twice the number of photon-electron interactions, lose twice as much energy, and hence twice the redshift. Using fast radio bursts, we can test predictions made by the theory. Radio signals from FRBs interact with these same electrons in the IGM and experience a dispersion measure DM. Since DM and redshift in NTL are both produced by photon-electron interactions, NTL predicts that a graph of DM versus log n1 plus z will be a straight line of gradient MC over 2HR. 7 years later, i.e. this year, we've got 65 localized FRBs, and it confirms that prediction to within 3%. And passive electron, big of light,
All right, we're gonna
All right, welcome, Lyndon. Welcome.
I think we need to have some kind of rule for math where it's like no spoken math to begin with.
No, it's fine. I think we can make sense of this. All right, so Lyndon, you're so guys, if anybody's trying to catch up on this, here's the weird thing about cosmology right now. Matthew brought it up. He was like, the cosmologists say the universe is expanding. What the hell does that mean? Well, they see light that's really far away and it's red. And so just like a siren on the highway moving away from you, they're saying the frequency goes down because it's moving away from you. And Lyndon's saying, no, the wavelength goes down. Lyndon's saying the wavelength goes down because there are elastic processes in these atomic transactions that are bleeding the energy out of the system in its relay path to Earth. Is that a fair representation of what you're trying to say here?
Yeah, it is. The same universe is static. And we don't measure velocities. We do not measure these galaxies moving away. What we find is that the wavelength of certain characteristic frequencies are longer when we measure them on Earth than when they set off. Now, some people explain that in terms of Doppler stretching, and I'm saying it's that they've lost energy on the way. But the observation is not recession, not expansion. It's an increase in wavelength of certain characteristic wavelengths. So it's how you interpret that experimental result.
So one of the reasons that people don't like this physical mechanism for things seeming like they're moving away faster and faster as you go out to the edges of the universe is that things at the edge of the universe aren't as blurry as they should be.
Yeah, they say if the light is losing energy, it's got to be due to scattering. But you're saying it's due to...
Sorry, I've interrupted you. I'm sorry, I know.
I was just going to say that I think to clarify what Nastia is saying is just that in these kind of tired light theories, they're often shot down because people say, oh, well, the only way to lose energy is scattering the rays. And that would result in blurry images, which we don't see, and some sort of, chromatic distortion where certain wavelengths are affected more than others. So how do you respond to the fact that all the wavelengths are affected similarly?
It's in the firstly, the blurring of the image is a 1960s theory where it uses a Compton effect. The Compton effect can't possibly do it because the Compton effect is an interaction between a photon and a single electron. There's no way that an electron can store the energy. So the new photon has to be emitted simultaneously with the absorption. So it has to go off at an angle. Now, what I'm saying is we now know that the model of the IGM that was used to...
intergalactic medium.
Sorry?
The intergalactic medium, the stuff in between stars.
Yeah, that's right. Now, the usual idea is that it's a plasma of protons and electrons. And that's right. So from that point, you can't get Compton effect or tired light. But it can't be right. The things will recombine, You're reading all these books about this IGM being a plasma of protons and electrons, ionized hydrogen, but why don't they just recombine? So I've got a quote here, Chandra Deep Field South, we do not find any direct evidence of the so-called warm-hot IGM. So what is it? And what I'm saying is that dust in the IGM is being ionized by the photoelectric effect. So ultraviolet hitting the dust particles and it's giving off the electrons by the photoelectric effect. Now, there's several papers being produced that's working out the actual voltage to which these dust particles gets about 20 volts, something like that. But what they don't ask is what happened to the electrons. And I'm saying is the electrons have been given out into the IgM, and when you get a group of electrons by themselves with a proton fixed on the dust particles, they'll, because of their mutual repulsion, they'll crystallize into a signal with the crystal, which is
Lyndon, let me interrupt you. Let me interrupt you. So let's take a step back and can we lay on the table why this deserves explanation? Like, I think that a theory begins with a problem. Like any right, it's if you're trying to come up with a theory of gravity, it's like, well, why do things fall to the earth? If you're trying to figure out exactly. So like what are we explaining here? Like what's the problem that we're solving?
The problem is that in order for the Big Bang Theory to work, it's got to have dark energy and dark matter. And nobody has a clue what these things are.
Okay.
The crystal spheres, like the Greeks came about. So I'm saying is it's wrong.
I think again, kind of like Matthew, he's kind of pointing to actual mechanical processes insofar as we can call the elastic light transmission mechanical. He's pointing to those actual elastic mechanics as being at the heart of the energy dissipation that lengthens these waves of light as they travel across the universe, and that the IgM has been mischaracterized. The medium, all that junk in between us and the distant red stuff, it's been mischaracterized. It's actually able to do the job well. And it seems like a quantitative argument to some extent, which we're not fully capable of evaluating here. Chris, do you make any sense of this?
I'm probably not on anything, but I was kind of wondering how would gravity or movement, I guess, affect the light, or what you're trying to measure?
That's a good question.
That is a good question. How does gravity affect things? Does it affect?
It doesn't. It's purely a standard transmission of light. Feynman says is nothing more than an electron picking up a photon and emitting a new one. But the point I'm making is 7 years ago, I said that when there was one fast radio burst, when we get enough of them, the relationship between dispersion measure, that's the different frequencies of radio waves traveling at different speeds, and redshift would have a gradient of MC over 2HR, 7.32 times 10 to the 25 in SI units. And
oh no.
I was right. And that's the important thing. It made a prediction which was not known at the time and has later been shown to be true.
Hey, Lyndon, where can people read about this work? If people want to follow up more on the quantitative prediction side of things, do you have a website or anything like that they could go check out?
I have an out-of-date website. I've got a couple of books, Big Bang Blasted and Tired Light, available on Amazon.
Big Bang Blasted, I love it.
And
I love it.
Lots of papers on academia.edu.
Oh my, that's amazing.
Excellent. All right, Lyndon, come back. Start from the basics.
Yeah,
absolutely amazing. Tell us from the start.
Give Lyndon a big round of applause. Let's get him on here.
Thank you.
I think we got Sebastian coming on next.
No, it is Eugene is coming on next. Poor Sebastian. He'll have his moment. All right, I gotta figure out which Eugene it is.
All right, Eugene, welcome. We're going to put a minute on the clock for you, and we will count you in on the count of 3. Guys, hold on. What the heck? Where's your manners? Let's give Eugene a nice welcome to Paradigm Shift number 3. Come on, guys. Come on.
All right, and then Gary Barham, you are on deck. So, Eugene.
Let's count him in on 3. Let's count him in on 3. All
right.
Here we go. 1, 2, 3. Hit me.
Okay, it's a bit abstract. The boiling universe hypothesis, or the field-bearing matter hypothesis. So, what if gravity is not pulling but pushing? And there's a different type of matter that is mainly concentrated in cosmic voids, and it is pushing our matter out of these voids into galactic filaments. And so it's just like air bubbles in boiling liquid. Our matter can combine, merge, create complex dynamic structures and vortices. Another metaphor would be like a lump of dust and hair that you can find on the floor that is put together by electromagnetic and mechanical forces, but originally it's created by the flow of air in the room. So how would we test that? Right now, as far as I understand, we don't have the resolution, but we would need to observe the supernova remnants on the edge, so-called edge of the void. There are no like strict edges, but like the remnants that are right next to the voids would be asymmetric. Huge orbits like Jupiter size, but that would require decades of observation. Maybe something else, maybe something like Archimedes forces, but in gravitational effects. Again, large data analysis could point out some anomalies. Yeah, okay.
All right, guys, come on, give it up for Eugene.
All right, welcome. So, push gravity. Is this push gravity or is this something different?
Kind of, yeah.
Okay, so push gravity says that instead of pulling, it's pushing.
Yeah, I kind of got that. I was kind of thinking if I guess if I was thinking of it as a circle and I'm here, saying you're saying that instead of I'm feeling something pulling me down, I'm having something pushing on me or making pressure. I guess where's the outside of that? Or how does that work?
So, if I could give a shot at it, it sounds like he's saying that space has this kind of like low density form that's kind of like air bubbles that are pushing on all of us. So whenever we perceive empty space, it's actually this really low density like version of some ether that's squishing us all into place, basically.
Maybe not exactly low density. I don't know that. Like compared to the other presenters, I don't have like math and formulas here, but it's just an interesting idea. I think that it might be actually more dense in a way, but it's low interaction. Like I don't want to get cheesy and talk about like this is dark energy or dark matter, since you already had people who like showed more elegant explanations for the dark matter.
But I do like that Chris immediately stumbled onto the question that everybody has for push gravity, which is like, if it's push, where's it coming from?
Yeah,
Like,
essentially.
Because they get all that kick.
Yeah, like it's like, is there boundaries for this? Like, where do you start?
The quintessential issue with push gravity is everybody's like, well, if it's just streamers, like where is it coming
What's
from?
the container?
So it's like if you have these, so I keep wanting to call you Eugene, but I feel like that's not fair.
Yeah, no problem. Zhenya is
Zhenya, excellent. So it's like Zhenya's saying that there's this zone of influence but low interaction.
Yeah.
And yet but it has interaction because it's causing gravity. Isn't that a problem?
The thing is that, so again, it's just an idea. I had my like basic astrophysics course, yeah. So as far as I understand, there are no fundamental contradictions. Like I don't see why it should be like glowing or something else. It might be just a different field that we are not catching here. I've had some discussions with some quantum physicists. They say that we would observe this field anyway, but as far as I understand, we think that it should happen only like based on some assumptions that might be wrong, actually. They originate from specific math that is being chosen.
But what's a field, anyways?
No idea. I mean, I've been reading a lot.
No, you can't do that. Okay, rule number one of paradigm drift. You can't have anything in your theory that you don't know what it is. That's like...
you want to have like a complete explanation of this. Right?
Well, I'm just like, you can't have pieces that when somebody's like, okay, well, what is that thing in the corner? And you're like, we don't talk about that.
Look, it's a difficult problem. Like, you would not be alone in the fact that a lot of people don't understand what fields are, except that there's some primary readout of what's going on. And I think it'd be really cool for you to spend some time contemplating that part of it. Like, if there is a new field, what does it represent? Like, what are the actual things, the ether, Googles, or whatever? What were you going to say, Chris?
I was just kind of thinking, he was kind of saying air bubbles earlier, and if I guess if you had air bubbles pushing, etc., or pushing down, is there a spot like where there's more pressure? Or in this case, it would be more perceived gravity, or how does that part work?
Yeah. That's what I'm talking about. There could be some artifacts on the edge of the voids.
Like gravity anomalies.
Voids.
Is that? I mean, could that be in theory like a black hole? In theory, more gravity or more push? Is that where we're kind of going, or in a way?
It could be a visible deformation of remnants of supernova remnants, for example, like not completely symmetric.
I think it's a really good point, because black hole, whatever the heck a black hole is, they do seem to perhaps be associated, at least in theory, with these supernova remnants, right?
Peter, you're the astrophysics professor.
All right, Sebastian. All right, sorry, I keep calling you Sebastian. Eugene, where are you located, Eugene?
In Berlin.
In Berlin. Nice. We're going to be in Berlin soon, so keep it warm for us.
Yeah.
What do you do in Berlin when you're not creating theories of gravity?
I'm actually not creating theories of gravity. I do audio synthesis, like programming in audio field.
Hell yeah.
We had some chat about reverb plugins.
Oh, that's right. That's right. You design reverb plugins. That's so badass.
Yeah, kind of. Yeah.
It's kind of amazing. Chris Rainey, this guy designs his own plugins for like audio recording. He like builds the algorithms and shit. It's kind of amazing.
I was saying that'd be pretty slick. Get that on. See what we can do with them.
That's true. That's true. You can't see it, but Chris has put together an enormous pedal board for Shiloh's spectacle
for our space station today.
That's cool.
All right, Eugene. Well, dude, let's come back and talk about fields next time, man. Everybody, give him a huge round of applause. Come on.
Bye. Thanks.
Bye, Eugene.
All right, Gary, this is Gary Barham. Let's give him a big round of applause, people. Come on, let's give him a hand.
Hello, everyone. Hi.
Paradigm Drift number 3. Welcome. Congratulations getting pulled out of the hat today, Gary. All right, we're going to put a minute on the clock for you and count you in on 3. Here we go. 1, 2, 3. Hit us.
Okay, we're proposing a new model of light. In order to create the new science, we need to first understand what light actually is. And we are actually proposing that light is a composite particle made up of 2 separate particles, one of light and one of darkness. So if you go down to the quantum vacuum energy, the 0-point field, we see in the universe that at every point there's a 0 point. And on this side of the 0 point is our positive space. on the other side of the 0 point is a negative space or counter space. So a particle of light entering into our positive space from out of that negative space is a negatively charged particle and is called a photon. A particle of darkness leaving our space, our positive space, and entering negative space is positively charged, and we actually call that a gluon. What we see as a particle of light is both a photon and a gluon linked together, and they travel through space together as a neutral particle, or what science calls a particle with no charge. A particle of matter, that's then all the subatomic particles, can only be created out of this 0 point field as a force between the photon and the gluon, and the photon is pushed apart.
Gary, you can't just keep going. All right. So Gary holds, I think, the honor of being the person who traveled the farthest to come see us in Austin last year.
Yeah, down to New Zealand and then back up via Austin, back to the Netherlands where I live now.
So, and we're coming, and so you're coming from the Netherlands in June.
Yes.
To Sesimbra. Excellent.
Yes.
Okay, well, a significantly shorter trip.
It's local.
Excellent.
So particles of darkness. That's some dark
Yeah,
stuff right there.
Yeah, it's an interesting concept. Darkness is not just the absence of light, but it's actually a physical entity. And when I say particle, I'm talking about an informed energy vortex. So light is traveling as with the standard wave particle duality. But if you're looking at it as a particle, it's got this energy vortex. It's,
so what is this vortex? Is this like in an ether of some sort?
Yeah, you go down to that 0 point field. So the light is the first appearance of any form of energy, information, or matter coming out of the 0 point field, the quantum energy.
So it's like a wiggle in the ether. It's the most primitive wiggle that you can imagine.
Exactly. And that is the fundamental particle that allows us to create matter. And that what we're looking at is that matter is the pushing apart of those two particles of light and darkness, the photon and the gluon. So the matter comes in between us, quarks and antiquarks. And they can only push between those two particles. So those two particles are pulling, they're bounding matter together. And that's what we call the strong force. You can't push it any further apart.
So it's like you have these vibrations that are opposing, and our material world is the result of these opposing vibrations in this ether?
That's it. And that negative space is like a mirror image of our space. And it is where Neil Turok is looking at his mirror universe. But he's putting a mirror at that 0 point and reflecting our space back in on itself. What we're saying is that there's no mirror, there's actually a gateway to that negative space. So the negative space has as much energy and activity as our space. So the two are in harmonic resonance with each other.
So is... okay, go ahead.
Chris, is this clear as mud for you? Or?
No, what I'm kind of thinking, like, I guess what I'm guessing is he saying that basically like, matter is like separating a dark particle and a light particle, and kind of like an equal 1 for 1. Like if matter is, then
and that those like each one of these particles
for me to receive a light particle,
and each one of these particles is like a vibration in some ether. I think, from what I understand. So there's like two vibrations that are kind of opposing one another.
Yeah, that's it. And they're in resonance with each other, so they reach a harmony, a balance.
Like a 1 for 1.
Yeah. So are they... is there actually a different world, or is it everything containing this duality inside of it?
It's a different world, and that's where we step a little bit apart from Neil Turok, who's reflecting our world back on itself. It's a different world, so it has just as much energy in it as our world. So if we want to pull something out of the quantum vacuum, we're pulling it from a separate world that's as big as our world. So it's got unlimited energy. But you can't take it all out, otherwise we drain their world. So it's a give and take. And out of that, you create the matter and antimatter that we need to make all of our particles of matter, all of our atoms.
This
So
is
it's
a
the
real
fundamental
zero-sum version of the world, isn't it? This is like maybe the most zero-sum version of cosmology that I've ever seen before. That not only are there two, like, it's not only that there's a multiverse, which I'm like, okay, fine. But there's a multiverse where we take everything from them in order to build our own worlds. That's dark,
No,
Gary.
but they take it from us as well. So it's a give and take. And it reaches a very fine-tuned balance.
Can one pull more from the other or do they have to balance?
They always end up balancing, and that brings you back to our universe being built of matter and antimatter in equal amounts. So we're constantly finding that fine-tuned balance. This is the fine-tuned balance of our universe. Begins at that 0 point.
Amazing.
All right, Gary. I mean, I think that you should. I don't even know what to offer this one, Nastia. Honestly, I got no pointers on this. Honestly, I mean, I guess a good question for me whenever I hear an ether theory is like, all right, we got these vibrations in the ether. And the weird thing about the vibrations in the ether when it comes to electromagnetism is that they're polarizing vibrations in a transverse fashion. And so I always want to know what exactly is the subunit that's vibrating? Like, how is the ether vibrating? Like, I would love to be able to visualize the vibrations, maybe. And so,
what we look at is that there's 4 separate ethers for each of the 4 fundamental forces. So you're starting to look at a vibration between the electric force and the magnetic force, but you also have an interaction between matter and antimatter, an interaction between the strong force and the weak force. And the fun thing is, I'm going to present this as a poster presentation in Portugal.
All right, man. We'll catch up more about that. And we're going to do a paradigm drift live in Portugal in the great room of the hotel, so you can rejoin us for that one.
Looking forward.
We will continue our conversation. Guys, by the way, Gary, you said you're in the Netherlands right now?
The Netherlands, yeah.
And what do you do in the Netherlands when you're not coming up with theories of everything?
We're busy rebuilding our farmhouse at the moment. It's a 250-year-old farmhouse, and we're using nothing but ecological and natural building materials.
Oh, yeah.
So, come from a very basic approach to building.
That's amazing.
That approach flows on into a basic approach to how we look at our whole universe.
That's badass.
Yeah, that's pretty cool.
All right, man. Well, we'll see you very soon, Gary.
Visit.
And maybe we will take you up on that. But we'll see you in Portugal. So, yeah, man,
Okay,
thanks for
thank
coming
you.
by. Guys, give him a huge hand.
All right, so I forgot to say who's on deck, but it is Jack Neefus. So Jack, we're bringing you in, and then after you, we have Bradie Lee.
Do we got Keelan yet?
Keelan's not here yet.
Keelan. Come on, Keelan.
They might think that it's different time zone.
Pacific. Alright, Jack, welcome to Paradigm Drift number 3! Congratulations, you have been pulled from the bucket. Hat. Sorry, Tony, not bucket. It's a hat. It's a hat. We're not ripping you off, Tony. Anyways, Jack, we will count you in on 3. So we got a minute on the clock. Here we go. 1, 2, 3. Jack Neefus.
Mario Bildrips has discovered evidence from ancient building foundations that the physical axis of Earth's rotation has changed during human times. There is also evidence of a catastrophic event, possibly around the same time, such as the mammoths flash frozen with butterflies in their stomach. Here is one explanation. The sun appears to periodically undergo micronovas or other large solar events, including the one at the end of the Younger Dryas. While these are known to be disruptive, what is lacking has been a mechanism for how a solar event could change the Earth's physical axis. Now, as has been confirmed by various solar missions, the Earth is connected to the sun by plasma filaments or Birkeland circuits from both poles. In between the positive and negative cylinders surrounding them, there are double walls, which are hexagonally tiled at the molecular level. The spike in energy during a large solar event of any kind will energize the filaments and cause the hexagons to contract, thus tightening the entire filament and physically yanking at the Earth's axes. This has the potential to cause the many catastrophic events that we see at that time.
Hey!
Yeah, nicely done, Jack. So, are we due for another shift?
That's what I was about
I
to
don't
ask.
know.
So let me tee up the context for people who might be tuning in and who don't know anything about this. So there's a number of different theories that a lot of our climate cycles on Earth have to do with the actual axis of the Earth shifting, which obviously would put us down here in Ohio in a really gnarly position potentially where we'd be stuck under a glacier or something like that. And the question becomes, why doesn't mainstream astronomy and planetary science tries to explain that things just get cold sometimes, but it's really weird. And Bill Drips and other people have pointed out that the glaciers aren't centered over the North Pole during the glacier, like these glacial periods during the ice ages. The glaciers are centered over Greenland.
So it's like we have a picture of the Ice Age, where it's like everything just gets really cold. Uniformly from the top, it kind of like crawls down the edges of the Earth. But what Jack was saying is that during the last Ice Age, they're finding mammoths that are suddenly frozen in permafrost. Like mammoths that are so fresh that when they melt for the first time from the permafrost, dogs eat them.
There was, I think I was looking at something like this. It might have been a YouTube video saying that the pole flips so quickly that everything gets cold instantly, thus making it freeze like that.
But it's like it moves from the North Pole where it is now down to Greenland, which is why it's like Siberia was warm, then it got very cold, and it's not a uniform extension downwards.
And what Jack's trying to do is provide a mechanism using these really interesting plasma structures called Birkeland currents, where he's trying to say that the plasma from the sun is somehow tensioning the Earth or somehow applying physical pressure to the Earth in order to ratchet that pole into the wrong place all of a sudden. Is that right, Jack?
It's like
Yes, that's right.
flare.
Yes. Well, one of the mechanisms, there are various things that can cause a large solar event. Some of the things may, like the 26 million year cycles may be different from the 12 to 15,000 year cycles. But I think one of the things that can happen is that if the sun is a Z-pinch, a pinch applies there can be a constriction and a backup, and you can have negative material, especially from the South Pole, backing up and releasing periodically. And this may be one cause of it with the 12 to 15,000 year cycles. And that would also send probably a lot of electronegative material, oxygen, silicon, nitrogen, and electronegative metals out to the Earth. We're receiving them anyway through the fast solar wind, but this would be a big spike in it.
So you're saying we could predict this if we saw this coming, we'd be able to feel these things?
Well, I don't know how to, if we see this dump, as I think Ben Davidson refers to it as a dump, I don't know if we know how to measure that. We just not know it through these cycles. So
do you think that there's some kind of signature for this in rocks or in paleomagnetic records or anything else?
I don't know about those kind of markers. I was using the real recent ones. Well, this is a whole nother subject, but I do think that material from the sun can reach the Earth and be injected to it. It can come on top of the crust, like some of the electric geology that Andrew Hall is talking about with thunderbolts. Or it could go right into the seabed in the mantle, more or less.
So what I would love to see if you come back, I forget, Jack, are you joining us in Portugal?
Yes.
Awesome. Mm-hmm. So what I would love to see is if you could develop, maybe you can research some markers that we might be able to look back in history and see some traces of this. If you could brainstorm some markers, because if we could figure that out, then it might actually be something that we could look forward to in the future, like a weather prediction system, which would be pretty amazing.
There are some other things that I think are related to this. I think it could retard the Earth's rotation and cause the tsunami that seems to have gone over the Western Sahara. I think that if the old North Pole was Greenland, then that means that southern Alaska was warmer and was at a lower latitude. So there isn't need for this land bridge or anything. It's a warmer latitude, as well as the eastern part, the part of Antarctica east of Argentina that some people claim is on these old maps. That would have been more like the Falkland Islands and not so much like it is today.
So ancient people could have gotten over into America a lot easier.
I don't totally understand why it being farther south and warmer makes it easier to get across.
Well, it means that people could live there in fishing villages, like in Scotland.
Would there be any restructuring of the Earth based on water movement, based on things freezing and melting?
That's a good question.
That's a good question.
Yeah.
Could we see like any traces of those kind of water sloshings?
I don't know. I'll think about that.
Well, there's water sloshings on the Sahara, is what you were talking about, right?
Yes.
So there is like a bunch of really weird marks on the Sahara that make it look like water flowed across the sand.
We're kind of getting that with like in the Giza area with like across the bottom of the Sphinx, a lot of water movement and things like that. Is that kind of what we're pointing at?
Oh, that's interesting. I hadn't thought about the Sphinx as being contemporaneous, but Austin is in the chat saying absolutely 100%.
And then like the dark pyramid thing, which is like a pyramid frozen in ice, and they were saying if the axis had shifted and rearrangement of ice and whatnot had happened, then that's possible that could have been a tropical area at one point before it was frozen in.
Yeah, like how big of a Austin says 1,000,000,000% for sure. So how big are the movements? Do you think are they like a few degrees, or are they 90-degree rotations? Are they like that like tennis the tennis racket effect in the space station where it totally flips? Like what are we talking about?
I don't think the Earth is irregular enough for the tennis racket effect. I think it's potentially this could flip the axes over, but I'm not sure that's done that. There's a difference between the current pole and central northern Greenland, and that's what happened with a fairly large event. It could turn 90 degrees like the Chad Thomas thing with the CIA in the 50s, but I'm not sure that's necessary.
Hold on. Can we do Chad Thomas CIA in the 50s?
Well, yes. Gareth Samuel has a really good analysis of that.
We might have to chat him up about that in Portugal in person.
Yeah, he has a good analysis of that. It's probably not necessary to say the Earth flipped 90 degrees. And there's also a question of liquefaction and the crust slipping, which I think can be more easily explained by just the electromagnetic fields pulling everything at once.
So when you say the thing with the CIA in the 50s, are you just mentioning that there was some like weird book about crust shift that was classified by the CIA for decades?
Yes, and it was recently unclassified, and it claimed that the Earth undergoes a 90-degree tilt periodically, and that we were ready for another one. And this is behind some of what Ben Davidson is saying.
So I wondered about that.
I wonder if that's a real document. Like I've read that.
They've already said it's like a couple, like the pole moves like a couple degrees, like measurably degrees movement, which says we should be on the way for a flip soon.
Absolutely.
Uh-huh.
All right, Jack. Well, yeah, man. I love this. I love the way your mind's working with this. I would just say let's see if we can. I don't want to say test the predictions, but let's see if we can get some markers out of the past that we might be able to actually follow up on in this with, and let's talk about it more.
Markers that are better than the magnetic state of stones and campfires, which Stephen Goodfellow recommended, where I'm like, that might be a good marker, but feels vanishingly difficult to find.
All right, guys, let's give Jack a big round of applause. Come on, guys.
That was excellent, Jack. Woo, 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 woo.
1, 2, 3, 4. Who we got on deck?
We got Bradie Lee coming on.
Is Michael here with us yet? right, Bradie, guys, let's give Bradie Lee a big round of applause. Welcome to Paradigm Shift number 3. All right, Bradie, we're going to count you in on 3. We're going to put a minute on the clock.
We are going to put a minute on the clock, and Ryan Mckenna, you are on deck.
Ryan Mckenna, get it ready. All right, here we go. Bradie, on 3. 1, 2, 3. Hit us.
All right. So I got invited here off of a tweet that I posted that said, would y'all believe me if I said Christianity, Buddhism, folk religions, Western philosophy, and science could all be reconciled into a single worldview and that I have that worldview? So what I mean by this is I kind of had a big moral crisis for a few years during my PhD as I was trying to navigate how to bring healing to myself and to the world around me. And it was only when I turned to spirituality that things really started to click. And so I started studying different religions, especially Buddhism, which helped me read other religions as metaphorical lenses describing overlapping truths. And I started viewing science as a tool that can and should be guided by other deep traditions of knowing. So we have thousands of years of insight into the shape of the universe, so it seems stupid to me to discard that wisdom just because it isn't peer-reviewed by Western academics. So I think integration of knowledge, both ancient and modern, both spiritual and scientific, is how we start to begin to see the whole. And from there, we can step into a brighter future together.
Hey! All right, let's talk about it.
Welcome
Let's
home,
talk about
Brady.
it. Let's talk about it.
Oh.
You're in the right place for that. So,
Austin asks, what if Christ was electric like us? This is
that's the question.
Christ could have been electric.
So, Bradie, do you think that science and religion do different things, or you think they can be on the same team working together under a bigger structure? Is that kind of what you're pointing to?
Yeah, I think that maybe a little bit of both. I have a friend who kind of describes religion as one of the first sciences. Like it's one of the first ways we started going about how do we explain these things we don't understand. And so science is only like a natural evolution of that is the way I kind of see it. And so I think like working together, and a good example of how to use kind of like mysticism or religion for science is meditation. So like we discovered as Westerners, like through our scientific lens, how meditation can bring health. But like they knew that for thousands of years, right? And so I think that like we can start bringing these ideas together and try to make a little bit more coherence out of all of them together.
Where were you studying in grad school?
UC Berkeley.
Oh, no, say what? I think soil biology?
Never heard of it.
Soil biology.
This is Charlotte's favorite joke.
What is it?
People tell him the names of fancy universities. He loves to do this to people who say they went to Harvard.
Yeah, let's do it. Let's try it one more time. Where did you go to school?
UC Berkeley.
Never heard of it. Yeah, I've never heard of it.
Oh, it's yeah. It's kind of a small school.
I love doing it to Harvard people more than anything. But no, what did you study there though?
Soil biology.
Oh, cool.
Like soil microbiome science. So like molecular biology.
So it's funny because I feel like soil microbiology in general is a gateway drug to spirituality.
Whoa.
Absolutely.
Okay, break that down.
Bradie, do you want to break it down for people?
Sure. Yeah. So like I looked in the soil for 8 years straight, right? And so I started learning about the microbiome and how like nothing is separate, and that's a very big like Buddhist concept, dependent origination. And so I also kind of, when I started studying all these things, I kind of landed on what am I looking at this for? What are they doing? What's actually going on in the soil and the plants? And I actually landed on they are loving each other. And that's all we do all the time is I was trying to figure out how do I guide myself and what patterns do I see? And they are always cultivating each other by loving each other and creating harmony with one another and suffering for one another. And so at the core of everything is cultivating love and life is the way I put it.
That's really beautiful. I think that there's something about looking at bacteria and realizing that you've been told your whole life that there are these absolutely simplistic things that are
soulless little wormy things.
Even worse than worms. Like worms, at least you pick up off the sidewalk. A bacteria is a thing that you want to eradicate.
Antibacterial.
Costs, right? They're the worst things to ever happen. And then you start studying it and and you start to really see the emergence of all complexity. Like, I studied biofilms for my PhD. And so it was...
Where did you go to school?
UC Berkeley. No, I'm kidding.
I just heard about that one.
Yeah, it's a good school.
My friend Bradie goes there.
But it's like, it's insane. They're such complex organisms. They're complex environments. They're sacrificing themselves for the betterment of the community. The line between a biofilm and a multicellular organism seems really blurry, and then you start to push on that, and nobody really knows why you can't call them multicellular organisms, because they have all kinds of crazy things that are growing together. And so I feel like it just, when you spend 8 years looking at bacteria, nothing ever looks the same again.
Totally.
What do you think is
that was definitely my gateway.
What do you think is the craziest thing that you saw in those 8 years?
Like, what kind of projects?
I thought it was crazy that I could see everything as love. Like,
what kind of like collaborations were going on with the bacteria?
Like, what kind of love were the bacteria having?
Yeah. What kind of expressions of love?
Chris is barely holding himself together.
They have paid very close attention for many, like, millions of years to understand how to give and take. So they are learning how to give each other resources, how to accept them, when to suffer for the other partner. And so they're really, they work very hard together to create more of one another. And I think that is just love.
Do you think they go to war with each other too?
I would say so. I think that,
but only out of love.
That's
like,
where
it's a very loving war.
Yeah, yeah. Maybe it gets out of balance when one partner takes too much, and that becomes war. So this is how I might say.
You know what's really interesting is that there's a Western way of doing science, which is super molecular pathway specific stuff based. And then there's this sort of Eastern Confucian way of looking at the world, which is on the basis of principles. And so I feel like this is kind of reaching into that realm, which is like, well, what are the principles? And it connects back to Ricky's stuff too, because he's saying that, okay, there are archetypes that we inhabit. And my most radical theory is that archetypes go all the way down to bacteria. Like, there are bacterial archetypes 100%.
As above, so below.
Right? And so I think that there's something that's so inherently valuable about seeing, like, what are the patterns that work down there? What are the patterns that don't work down there? How do things fall apart? How do things grow and become more complex in such a way that it reflects backwards on our own experience?
Totally. And maybe, like, what I'm interested in is, like, how do we project these ideas of soil onto, like, the next layer of consciousness, which is, like, the idea environment. So how do you reflect everything above as we're coming into this era where our idea environment is new and it's very unbalanced and not quite stable yet? And how do we reflect the below patterns into the above patterns as they come into being?
Oh man, I would love for you to come back and break that down a little bit more and, like, kind of paint a picture of what it looks like when our internal idea space is in some way parallel to this out of balance warring situation with the bacteria that you encounter sometimes in disease and so forth. That'd be really cool.
Totally.
I love it, Bradie. I appreciate you coming out here. Congratulations.
Yeah,
Paradigm shift number 3. Bradie, are you coming to Portugal by any chance?
I am not.
All right, well, maybe next time.
Thanks for asking.
All right, guys, give Bradie a big round of applause. Thank you, Bradie. I hope you come back next time. Thank you, Bradie. Come on, guys. Come on. All right, who's on deck?
Thank you for coming. So on deck, we have Wayne. And before Wayne, we have Ryan. We have Ryan Mckenna. All right. Welcome. Oh, no. Hold on. Everything's all right. Don't
We've
panic.
lost our screen. Everybody hold on one second. All right, Ryan, we got you. We're going to put a minute on the clock for you. And welcome to Paradigm Shift number 3. And we're going to count you in. Wait, hold on. Let's give Ryan a round of applause. What do you think, guys? Come on. Welcome. Paradigm Shift number 3. Absolutely. Absolutely. That's how we do it. All right, guys. Let's put we got a minute, and we're going to count you in on 1, 2, 3. Hit us.
I stumbled on I was trying to solve TSP using electricity, and I got an equation, or I simulated it in Python, and then been working with AI with it, and it's called or I'm a little nervous, sorry. dg by dt equals alpha times the absolute value of I minus mu times g. And it basically adapts electricity. It auto-tunes its own resistance on the fly. And I've since simulated gravity, and I turned it into a new type of geometry, a non-Euclidean, because it was making curves because it simulated gravity, it was making these curves. So I was like, so can we draw curves using this? And it came up with adaptive pi, which then eliminates infinities, and it makes black holes. And then I actually added curvature memory to where when you're going from one node to the next, it remembers, because of the pi adaptive curvature is so precise,
all right. Come on, guys. Give him a little bit.
A little bit.
A little bit. All right.
Okay, so you committed the error that many theorists do at the beginning, which is that you did not tell us the problem that you're solving. You kind of start your presentation in media res. It's very, the Odyssey in its nature. But it's very confusing.
It seems that everything in electricity I apply it to, it seems to work.
Well, I don't know what
I was originally
it
trying to
is,
do,
Ryan.
I was trying to solve the TSP,
I don't know what that is, Ryan.
traveling salesman problem.
Oh, okay, so this
it's an
actually
NP
is...
hard problem.
Okay.
All right, let's introduce people to the traveling salesman problem so that we're all on the same page really quick. And by the way, if you come back, I would recommend that you put that in a sentence at the beginning. But go ahead, explain us the traveling salesman problem.
It's basically if you've got, like, say, 20 houses you got to travel, or you got to make a schedule to visit that day. The math keeps getting harder and harder as you add more cities to it. So I think like 10 cities is like the math. When I was younger, I've been working on it my whole life, they said that, say like 20 cities, once you get to a certain spot, it would take 100 computers 1,000 years to do one route. So it just keeps getting exponential.
Can we, so before we get farther into this, can we explain to everybody in the room, like the traveling salesman problem is, like you said, you have this list of places that you have to go to. And then the question is, what is the most efficient route? What is the shortest route between each location on your list, right? Mm-hmm. Like Boston, Philadelphia, New York, Los Angeles, San Francisco, Boise, whatever. For whatever reason, this is a really difficult computational problem to solve. Like, you would expect, like, I don't know if you've ever noticed, but if you try to plan a road trip, there's no computer program, there's no service where you can be like, these are the places that I want to go. Tell me what the most efficient route is to hit all of these places.
Like we were doing this with our tour last year. We were playing with our band, and we were trying to figure out, all right, we want to play all these cities on the way from here to Austin. What's the best way to do it? And there's no generalizable solution to this problem, which is freaking crazy because this is the land of lasers in the jungle, and, everything's million miles an hour these days. Why can't we do this problem?
Yeah, like, can you explain why this is such a difficult problem to compute? And why it matters. Let's start with why it's difficult to compute.
The problem just keeps getting exponential. I wouldn't know how to explain that. This is way over my head. I do like hobby programming, and I've been trying to figure this out forever. So it is over my head, but
Okay, so
I actually,
yeah, so if I could say this. I think that something that's very important for theorists is to understand the depth and the complexity of the problem that you're trying to solve. Because I'm like, at the end of the day, if we're proposing solutions for something, we need to understand the problem really well, right? And so if no one that I've seen has been able to explain this computational issue very well, and yet I feel like that's your task, Ryan, in this space.
I at first I only got the best heuristic, which is I was doing better than anybody has before, and but it's more of a approximate. It just gave you a strategy. But since then, when I came up with the adaptive pi, and then I put the memory curvature in the route, I actually solved it. Now I could do like 10,000 cities in seconds, and then applying the adaptive curvature, it like. That's just the beginning. Like everything I apply it to, I've made an AI optimizer. It makes AI better. I've applied it to a Bluetooth. Bluetooth was the first experiment I did, and it extended the Bluetooth signals further than standard Bluetooth. I can make a better welder with it. I made I've got a website or a GitHub, and I've got it'll simulate the two slit experiment. Where it simulates it, and it also will simulate Redshift, and it also
you need to. I can't tell if so. We have a patron. His name's Sebastian, and Sebastian has also been building something that does. I don't want to say does the exact same thing, but it is some kind of model that optimizes a tremendous number of things. And I predict that you and Sebastian will either be absolute sworn enemies a la Highlander, where there can be only one, or you will be extraordinary friends that have discovered that there's somebody else in the world that cares enough about these same questions.
Chris, does this any of this make any goddamn sense to you?
I mean,
Chris is our watermark.
Yeah, he's our canary in the coal mine.
Yeah.
Are you following any of this presentation?
On this one, not as much. I mean, I think I get it. Yeah, I mean, in the sense of if you're just trying to make the best route, it gets worse the further out you get. That's the part that I've gathered from what I have so far.
But it's like, why is that? Like, I've never understood why that is.
Is it just because there's more space the further out you get? If you were thinking of it in a circle, this circle has this much volume, this circle has this much volume,
or possibilities,
so on and so forth. Is it one of those kind of extrapolations?
I like that a lot.
I like that, but I don't totally understand how Ryan's quantitative model solves that problem. But maybe hey Ryan, do you got a website or something people can go check out?
Yeah, it's GitHub RDM3DC.
GitHub RDM3DC.
Throw that in the chat when you get back in there. Look,
yeah, I think we should keep it moving personally.
I think so too. I think that you should come back next time and you should explain to us why these things are so hard to calculate, and then actually explain how the thing that you've designed fixes that problem.
Exactly.
That's what I'm saying. Is it just exponential volume?
Well, that's what somebody in the chat said, that it's like, yeah, just because it's more space, you have more degrees of.
But we need to know how his model actually addresses that issue. So, all right, let's bring it back around. Let's keep it moving.
is really just the start. It solves almost all the NP hard problems. I've thrown it at everything. The SAT.
So, okay, I don't understand the PNP. So this like class of problems, I don't understand very well, and so consider this a bounty. Like whoever explains this class of problems to me in a generic way that can be applied to every single problem in the category gets to come back as a regular the next week.
Hey Ryan, before you go, man, where are you located?
In California.
What do you? You're a programmer by trade?
Yeah, more of a hobby. What
do you do for a living?
What was that?
What do you do for a living?
I'm a surveyor.
Surveyor, that's pretty cool. So
that's kind of how I got into the adaptive pi and the non-Euclidean geometry stuff, because I try and reproduce curves and I always get errors in the curves. Nice. So I was trying to, and I originally thought it was the northings and eastings were infinite. but they're
This
not.
is the path into it. This is actually amazing. So next time when you present the theory, start with your lived experience of what you noticed and the thing that didn't make sense, and then lead us into the thing that you figured out that solves it. Like, get us into your space first of being like, this doesn't make any goddamn sense. And then give us the thing that solves it. I think that would be super good.
All right, guys, let's keep it moving along. Thank you so much.
Thank you, Ryan.
Ryan, absolutely. You did it. Congratulations. Paradigm shift number 3. Let's keep it going. Let's keep it moving. Who's on deck?
So we got Wayne, and then after Wayne, I think that we should do... I think we should do Michael after Wayne.
All right, Wayne is on deck, followed by Michael Hughes. All right, Wayne, welcome to Paradigm Shift 3. We are going to... Hey, guys, where's your manners? Let's come on. Bigger than that. Come on, this is Wayne Coste, longtime supporter of the podcast, and we are super stoked to hear what he has to say today.
I really hope this is a September 11th theory.
Well, I don't know if YouTube is going to be able to stomach that, but we will see what happens. All right, let's count in Wayne on 3. Are you guys ready? 1, 2, 3. Blow our minds!
Cosmic redshift, elegantly explained by Minkowski spacetime and general relativity. For nearly 100 years, cosmic redshift has been explained as the result of expansion of space itself, which causes light and the wavelengths to be stretched and lose energy. So far, no mechanism has emerged to explain this phenomenon, except earlier today. However, an asymmetry in where energy can be known to a photon can result from the speed of light constraint. Because gravity can be viewed as an attraction between energy, a perceived asymmetry in knowable energy in the forward direction compared to the knowable energy in the reverse direction can create a dynamic differential in gravitational attraction. This asymmetry can arise as follows. If we assume 2 atoms on opposite sides of the star, each atom will have an electron that gets excited and emits a photon traveling in opposite directions. Nothing will know about the energy in this photon because nothing can catch up to it and know about it. On this side here, if another photon's coming at it, they can't know about each other because they're both traveling at the speed of light in each other's future light cone. Only when they pass each other and their past light cones overlap can they know about each other, exchange gravitational potential energy for kinetic energy, and therefore the basis for cosmic redshift. Assuming constant flux in the universe, this mechanism would be linear with distance.
Yeah, all right. Let's unpack it. Let's take it apart. Come on, guys, give me a hand. A little bit of something. Come on, guys, come on. This is Wayne Coste. All right, Wayne, we got an energy balance to deal with here, it sounds like. We're
So
the dirtiest word in all of science.
I wonder if before starting with the questions that are scientific, I'm inspired by Ryan. Wayne, how did you get interested in this question?
In this particular question?
Yeah.
Well, back when the pandemic started, I started rewatching a lot of astronomy stuff. And one of the questions I had was, what happens to the light when it leaves the universe? There's got to be some effect, right? And then
leaves the universe, meaning like gets to the edge of the universe?
Light goes someplace. Where does it go? Does it have any effect? Or is it too trivial? Well, and
I always thought it went to other atoms.
Well, no, like what happens to like a ray of light that gets to the very edge of the universe?
Well, the atom at the edge of the universe kicks it back, I guess.
No, like what if it goes in between 2 atoms at the edge of the universe?
And just sets up like a resonance between them?
Well, I have no idea. That's a crazy question. I'd never thought about that.
Chris Rainey's got something.
Are we assuming a boundary then?
That's a great fucking question, Chris Rainey. Do we assume a boundary?
No, there's no. As near as I can tell, I mean, when you go down this particular framework, what you identify is that we're most likely in what Newton thought was, and many others before him, that the universe is infinite in time and space, and there's no such thing as a boundary. It just keeps going, and the light will eventually, the light will eventually keep going, and it will keep getting redshifted by all the other photons and gravity waves coming at it, slowing it all down, and eventually it'll merge into what I suppose would be the ether. But there's no end for it. There's nothing for it to end in, as near as I can tell. The Big Bang. One of the aspects of this came from the question: could the Big Bang be explained, or the gravitational, the expansion of the universe be explained by the Big Bang emitting an enormous amount of energy that's radiating, and then the universe would be pulled by this light that's going out, because it all has energy, it all has gravity, and because of the Boltzmann, the temperature to the fourth power, T to the 35th degrees Kelvin to the fourth power is a huge amount of energy. It could maybe be pulling the universe apart. So I kept wondering, where is the energy in the light? Whatever happens to it? And I was trying to come up with a way of figuring out using LIGO. Could it be detected? And then I stumbled on the very nice symmetry of two photons passing each other and exchanging gravitational potential energy for kinetic energy. Tried to figure out how to actually quantify it. Couldn't figure it out. I've got a couple of ways you can probably potentially quantify it. One of which, am I talking too much?
No, I have a question. So did you figure out what happens to the photon that gets to the edge of the universe?
No, it keeps on going. I figure that it eventually loses so much energy, it will get absorbed into the thing called the ether.
So you
Is the ether a dissipation to zero?
Whoa, that's a really interesting question.
Yeah, is ether like absolute stillness at the edge?
Well, we know from the Casimir effect, there's a 0 point energy. There's something below the surface of where light goes.
So just in case somebody doesn't know the Casimir effect, can you give it to them?
The Casimir effect is you can have two very thin plates together, and they will be pulled together, and it's not gravitational. The theory is that there's a lot of waves going on, and between the plates you can only get a limited number of them, and so the ones on the outside kind of push it together. And so these wave energy things is what some people talk about as the ether. But eventually, under what I was proposing, all the light will eventually run out of gas, so to speak, and will be absorbed by this ether. And
so
by
is
the way,
the edge of the universe really blurry? Like, if you come to the edge of the universe, which is some fraction of brightness. No?
I don't know what you mean by the edge of the universe. I don't know what that means, because you always go to the next delta t or delta x, dx, right?
We build a bigger telescope.
Okay, well, is there a limit to the amount of energy that photons have in them over length traveled, where at some point
Sure.
the edge of the universe is literally a feature of photons losing energy over distance?
No, because, well, first of all, the photon emitted way out over there is still got that same amount to go before it loses energy too. But one of the other things that I've said is every time these two photons pass each other, or even gravity waves, a photon passing a gravity wave will lose some small fraction of energy, and eventually it will have, once it has gone past the equivalent of a black hole's worth of photons going in the opposite direction, it will lose all of its energy. it will be gravitationally redshifted to zero.
Is there an edge of the universe?
I was like, the only thing I was thinking about was like a vacuum, like on the edge, or zero. Like I'm still trying to sort out that whole exchange as the energy, I guess, leaves or passes each other, as he was suggesting earlier, to a zero. I'm still trying to.
Like, is there a zero?
I'm trying to wrap my head around where the exchange ends.
Yeah, like, is there a point where everything goes to stillness?
First of all, the amount of energy in photons is very small compared to the total mass and things like that. So I'm not sure I quite understand the question, but eventually.
Well, okay, the question is this: like, is there a bubble in which stuff is happening, and then on the outside of that bubble, everything is just perfectly still?
I'm envisioning that there is no such thing as a boundary for the thing called the universe. And the further away we look with James Webb, the more we find stuff. We have the assumption that somewhere at Z equal 1100, that's where the cosmic microwave background is, or that's as far as we can go and see. But if in fact, and there's a relativistic equation that's used there, but if it's linear, it's a whole lot further away, I think. So,
what do you think about Carver Mead's point that you can't have light without two atoms? Like, light doesn't just travel off into the distance; it's only a transaction between atoms.
I tend to like the classic. You have a dance between electromagnetic and electromagnetic and electrostatic, creating the traveling forms. You know, I'm an electrical engineer. That's where
he's a Platonist. We have a Platonist. We have a forms Platonist here at the table.
And I need in my mind to develop a physical model of the world. I don't like the math tells me this stuff. It might be a good tool, but I keep looking for the physical mechanism. And so I came up with one with the photons passing each other, that there is nothing sitting in the corner that anyone's been able to identify yet. And
I like that.
So
I like that. Wait,
I don't think a Platonist who's about to defect to the atomist side of things.
This is true. The mathematician. Anytime a mathematician starts to embrace what is it made of, their Platonic days are numbered.
That's when we're cooking with gas. So Wayne, are you coming out to Portugal? Remind me. I can't remember.
Wayne's coming. He's also bringing his lady.
Oh heck yeah!
We're gonna get to meet Mrs. Wayne.
Yeah, Mrs. Coste. All right,
and,
Wayne.
Today it's her. And today it's her birthday, so I was good.
Oh my goodness!
I've got the poster, and I've sent off the abstract to Patrick, and you guys are awesome.
Oh, Wayne.
Wayne, we appreciate you so much. Wayne's like a constant presence at our patron chats. He's been with us. He's a real one. He was in Austin.
Oh, man.
So thank you so much.
All right, Wayne. I'm stoked to see you in Portugal, man. And we'll catch up about all of this there. All right, guys, give him a big round of applause. Wayne Coste, Paradigm Shift number 3. Congratulations, Wayne. You did it again.
All right, so we have one of our regulars, Michael Hughes. And I know we're almost at time, but I have an announcement that is going to shake the foundations of the world. We're going to do one more after Michael Hughes. And it is going to be Sebastian. I know Sebastian has been gunning for this for weeks. And I was going to call it after Michael, but I think we got to give Sebastian some time.
Yeah, Michael, I see your mic is muted there. All right, welcome, Michael. We love you, Michael. Welcome back. And let's put a minute on the clock for Michael. And we will count you in on... Oh, shit, I always forget to give people... Come on, guys, let's clap for Michael. Welcome back. Come on. All right, there he is. Guys, come on. Where's your manners?
All right.
All right, we got a minute on the clock, and we're going to count them in. 1, 2, 3. Hit us!
So the lens I'd like to address today is that the lens of science and the lens of spirituality often have trouble talking to each other, right? And so how I meant to do to help this along is to find some common ground between these two lenses. So what I propose is that something that that my paradigm shifting idea is that something that science and spirituality both agree upon is the concept of water as an energetic mirror. And so in science, I talk often about how things that you dissolve like salts or proteins into water, they change the structure of water around it and exactly as much energy as they add into the water. So the energy of dissolution the free energy of dissolution actually correlates directly with the structure change of water around them. And so spirituality also deals with water as a mirror beyond just like scrying or some traditional practices, but also in this concept as above, so below that we've heard tonight, where there has to be some medium through which, if there is a spiritual realm that like translates into the physical, and water seems to be that role.
Oh my goodness, guys, come on. Michael Hughes. All right, putting a beautiful bow on a lot of these discussions tonight. Wow, so you think that the spiritual realm reflects the physical realm in this really beautiful parallel fashion?
I think that I tend to not have like many of my own thoughts these days. I think that it's like interesting to like sample these other viewpoints and then see how they synthesize it. And I tend to be gravitated towards viewpoints that are like self-cohesive through a mechanism, right? And so I'm a structural biologist. This deals with like the real physics of mechanism, how like proteins and waters move around. And so I like paradigms that have that as part of them. So the idea is that like there is a realm of causality, and our physical sciences really struggle with causality, I think, right? Like when we're talking about entanglement, it's really hard to get around that you, the experimentalist, bought a piece of metal from someone that had mined it and then shipped it around the world to like look at yourself in a mirror as to what you're curious about, right? We tend to like only focus on the atoms, but there is this causality from maybe another plane of why did you be interested in looking at those atoms in the first place? Why did you coordinate or orchestrate them into a strange experimental apparatus? And so in this way, there has to be some way of like potentially a spiritual motivation translating information into our physical reality. And this is where like as above, below comes from. And there's a certain like, some physicality and interesting parts about water in both our physical sciences understanding and in the spiritual understanding that seem to like link up nicely with each other in explaining this.
Chris, are you following any of this?
I'm still looking. I think I can get this one. I think I can get this one. I was on board with the framework of the topic, but I'm trying to catch up.
All right. Okay. So let's break it down. So Michael's background is that he's a water guy. Like Michael has been studying the esoteric behavior of water. I'm sure that we've mentioned him this weekend while we've been staying here. We're like, there's this guy. He looks at water. It's doing crazy things.
Can I just say, like, water is 99 out of 100 molecules in your body, and nobody talks about it, right? Everybody's like, the DNA did this or whatever, and it's like, yo, what was the water doing? That's most of the stuff inside of you. And Michael's like, look, the water's doing stuff. It's actually structuring itself in interesting ways. It's pulling the proteins around. Michael's cat probably has thoughts about this as well. So, sorry, Nasi, I didn't interrupt you. I was just clarifying that.
No, that was great. I'm sorry. I was preoccupied by the cat. I'm just like, I think that that's exactly right. So Michael's whole point is that water is doing stuff. Now, with that as your starting point, bring it full circle to this question of spirit.
What's the water of the spirit?
Yeah.
What is the spirit of the water and the water of the spirit?
So I guess the question is like, how is your body like animated? So let's say like,
that's a really fun, like, why is life alive?
I want to hear more.
Again?
Like, why is life alive?
Why is it moving?
So I like that question too, like, why is life alive? So the first thing that I talk about is like, life is an out of like equilibrium, out of thermodynamic equilibrium system. So something has to like draw you out of that in the beginning to like create this energetic like deficit that draws, food and water and all these things into it and excretes something out from that. So there has to be, in a sense, it's like animating force to cause that like organization. And the scientists might call this like a low entropy system, right? Something that is like highly organized because the world like tends to fight this. And this is something that like when talking about like more spiritual beliefs of theosophy into anthroposophy and like Steiner kind of material, Steiner has specific ideas about how the mineral world, the kind of mineral like your skeleton dissolved in your body, like reflects light through water. And so in a sense, like water is the conductor of light, but it's reflected by the mineral realm where it like doesn't penetrate. And so in this realm, it's the water that's this like medium that's like allowing some information through from this potentially spiritual realm. So now we're talking back to like science, like what animates you to move your arm, right? The scientist who's the physicist trying to study entanglement has to go get those metal atoms from the mountain and bring them into like a microscope. Lots of arm movements there, like all very motivated by strange like things that are strange to quantify by like billiard ball collisions of atoms, right? So there's some strange organizing principle that's like leaking into here. And again, it seems that like water is this really interesting physical medium that allows this information to seep into our body and help animate it in the ways that we want to, right? And so the idea is like our body and nervous system actually seems to make this really, really weird Rube Goldberg contraption where it's kind of like if you needed a lever, so if you need the smallest amount of energy, let's say the momentum in a photon to make the largest movement, which might be like a lever of like moving my arm, how do you build a system which can like amplify that energy? And it turns out that the water structure that your body creates these really, really strange like entangled water domains. Some people call it as like quantumly entangled water. And this is kind of the low density or easy water that Jared Pollack talks about. And this is primed for absorbing like rare photons or interesting like photons of light. And so in a way, your body is specifically built as this giant lever where you can turn light into physical motion. And so in a way, you could potentially transfer information from this odd realm into like mechanical action in the 3D realm through water being this antenna.
Whoa, all right, this is awesome because all night we've been talking about the medium of all of these things. And what's really funny is that the cutting edge modern science does not want to deal with media whatsoever, right? So everything is mathematical relationships between phenomena. Nobody wants to talk about what's waving during a light wave. It's a wave. And so water is kind of doing the same thing. And the question is, what is the medium in a metaphorical sense of spirit itself as well? What is it? What is that animating principle that appears as resonant modes? You know, Ricky opened up tonight by talking about these archetypical forms, which are almost like standing resonant modes, right? They're these spiritual modes that we keep coming back to over and over and over again, right? People sort of like fall into them. Am I making any sense to you? Does that sound reasonable?
I think so. Yeah.
Who is this, by the way?
Yeah. This is our cat Simba.
Simba.
Yeah.
Welcome to the show, Simba. You're the first cat on Paradigm Shift.
Is Alexandra working the camera?
Yeah. My partner Alexandra is working
Alexandra, it's the first time we've seen you. That's amazing. Good to meet you.
She snuck into the background of the other one. I'm glad that everyone's here tonight. But no,
adorable.
And I think I've lost my train of thought. Sorry, but resonant modes of water of
Well, it's interesting. Like the archetypes for Ricky, who opened the show. Ricky was saying that there's these archetypes that manifest themselves as these, and I'm kind of putting this on him, and he'll tune me up later if I'm not saying this right. But it seems like they're kind of resonant spiritual modes. They're these patterns that people tend to fall into, right? That seem to be harmonically balanced. And when the harmonics get out of balance, you get these discordant societies. And when the harmonics are actually in tune, you get these really consonant, nice, harmonic societies. And yeah, I wonder if you can comment on that with respect to the water analogy.
And I do like this like concept of harmonics as like love. Like love is like waves overlapping, right? Where like you're in a community, people are like in the same, on the same planet doing a similar thing. You're in a family and people hear each other and get each other. You're in a forest and the ecosystems are intermeshing and like talking in the correct way, right? And so at the like essence of this is like a continual like water network, like mediating all this for the first part. But then like what's interesting is like I think that hate is also like love, right? Like I know my cat. No one loves the birds more than Simba, right? But the birds consider this hate. But the thing is that like he's so like in phase with the birds, right? It captures so much attention. And the thing is that it's like in a sense like anti-phase, right? Like Simba wants one thing and the birds want the exact opposite. But there's still this like connection of like love because they're so in phase with each other, right? And what I think that hate or like discordance actually is like a lack of any phase, right? Just pure chaos, right? And this shows up in my crystallography background because when you look at a crystal diffraction pattern, the brightness of the spots tell you how like on top of each other the waves are in the diffraction grading, or how if they're dark or if they're not there, then it's because there's like there's no overlap of the crests. But the space in between the crystals is because it's disordered, right? Because there's nothing cohesive there to like generate a signal to throw.
Is there anything like
that's what hate feels like? A discordant node in the crystal, right? Doesn't produce light. There's no coherence there.
Chris, what do you got, man?
Is there anything like since like I guess water is conductive? Is there anything electrical or measurable?
So yes, on both sides. So first of all, I think that like the human body has these resonances of motions of molecules and corresponding motions of water, and this is AC electricity, right? Your nervous impulses, your heartbeat is an alternating rhythm, right? Every time you breathe in or out, or your heartbeat, it changes the dipole nature of your body, and EMG is literally measuring the change in your like magnetic dipole or like your electric moment. So in a way, there's like definitely AC bioelectricity here. If we look from a spiritual lens, I always adopt this like anthroposophy lens by Dr. Steiner because that's who I know, right? That's the only one I know to draw to. But he talks about humans as mediators of different spiritual beings, and that one of these is the one that like dominates the electrical impulses. He calls this kind of like the aramonic being. And so in a way that the electrical ability of our body is actually like mediated by these spirits that are conducted through electricity in the water of the body.
Whoa. All right, where do we go from this?
Where do we go from this?
I guess what would be really interesting is to map, like if you could think of some way of measuring this in individuals where we could correlate it with behavioral or personality or archetypical like life forms, let's say, or patterns of life. If there was some way that we could somehow correlate these measurably, that'd be really interesting.
Right. So an odd thing that I'll pose to you, and this is also like fun thought experiment, like I'm trying to like build and synthesize different things into like one common language. So there's experiments where people like make snowflakes with different emotional states. Like you freeze water when you're angry, you freeze water when you're having a loving disposition. And so they'll claim that they like snowflakes with the frozen water like looks different, right? Different emotional patterns lead to different crystal structures. And so, most things have like an identical crystal structure, don't have this, but water, because I'm posing is this like strange energetic mirror, that when your body is in a different emotional state, you emit literally different colors of light. I'm not talking about like blue, green, etc. I'm talking about like, you have different chemical reactions ongoing in your body. So there's different coherent waves of like maybe exact like microwave or terahertz radiation that are always emanating from your body. So when we're looking at like, why does that snowflake, but why does that water freezing form a different crystal structure? In a sense, it's directly responding to the light that your body's putting off because it's capable of absorbing that. And then this water absorbing that energy, it rearranges its crystal structure. And so all this is like reasonably scientifically grounded, but at the same time can help us analyze this really weird, result. But also in a really like physical lens. And so in a sense, it's also like as above, so below, a reflection of something else that we're looking at, but it does have like a really physical manifestation, right? That we can potentially grasp now and like interrogate in a more like rigorous way.
I mean, maybe next time we can talk a bit more about these snowflake experiments and how we could do them. What do you think, guys? Chris, what do you got?
No, I was actually a little bit understanding about the snowflake thing. I've heard of that before, at least. So that's kind of where I was starting to tune. I was like, okay, now I think I know where we're going now.
It's so interesting. I feel like for the presentation of theories, we kind of have to assume that people have a zero ground, but that they've heard something somewhere a little bit, or they can relate to some kind of personal experience. And I feel like this is very much an experiment in trying to figure out how to tune that so that a theory can land. Because I feel like what you said, which is that I've heard about the snowflake thing a little bit.
Yeah, it's like they were saying something about the way, I guess, the the ways, or whatever way you're measuring it was the way it would make a snowflake form. Basically, if there's like fast waves or slow waves based on how it would hook up.
I think that it's like the ones that I've seen are emotional content. It's like I've seen one for tears.
Yeah.
Like happy tears, sad tears, angry tears all have different crystal structures, and it's funny because it's such an easy thing to test.
Mm-hmm.
Like you should be able to just I cry all the time. Like regularly. I can collect tears. Like I don't know why I haven't tested it yet.
Are we still gonna try to do one more after this?
We're gonna do one more.
All right, we gotta keep it rolling then, because we're down to 2 hours already. So I know we screwed up the beginning. Michael, dude, I love you. It's always awesome to see you.
It's amazing.
Thanks so much for having
Let's keep talking about the snowflake
I
thing
want to
next
hear
time.
Alexandra's theory next time.
Yeah, let's get
Okay,
Alexandra's something.
Paradigm shift with Alexander.
All right, guys, give Michael a big round of applause. Thank you, Michael. It's always good to see you, man. Peace out, Michael. Peace out.
Now we have the last theorist of the night. And it is Sebastian Schepis, who has been asking us for an audience for weeks. And now, finally, his moment has come. He's gonna get 60 seconds, just like everybody else. And the bucket holds fates for you.
All right, this is our last theorist tonight. Let's give him a big warm round of applause, my friends. Hey, welcome to the stage, Sebastian. We are going to put a minute on the clock for you right now, and we're going to count you in on 3. Here we go. 1, 2, 3. Blow our mind.
Hi, everybody. So I'm here tonight to propose a unifying framework, one where consciousness is inherent, where entropy and gravity emerge as coupled phenomena within a system structured by prime number resonance dynamics. At the core, conscious observation reduces internal entropy. This creates external gradients of entropy flow. That's what gravity is. In this model, gravity equals observational capacity, the rate at which information is extracted for quantum potential. Quantum information is encoded using prime number eigenstates. Each state evolves through structured phase coherence, simulating entropy-driven collapse, non-local entanglement, and resonance stabilization, all in a Hilbert space structured by number theory. This drives the quantum consciousness resonator, a symbolic AI system that interfaces with entropy fields, stabilizes attractor dynamics, and aligns symbolic structures with measurable quantum patterns. It's a spectroscope for consciousness. The result? A computational model of consciousness, a new definition of gravity, and a path to the completion of quantum gravity, falsifiable, testable, and grounded in hard science and in the primacy of the observer.
All right, come on, guys. Come on. Give him a little round of applause there, huh? Give him a little bit, huh? A little bit of love for our last theorist of the night.
So my problem is that I don't think I'm smart enough to understand what Sebastian is talking about.
Chris, did you follow any of that?
Well, I'm going to take her cue.
I know that Sebastian has figured something out because number one, builder, he's constantly linking things, like constantly making programs and finding these mathematical relationships between different features of the world and just like completely focused on trying to understand the resonant relationships of nature. But Sebastian, I do not understand.
Well presented, though.
All right, what problem are we solving?
Yeah, let's start there. What's our problem?
So where does everything come from? What is all of this? What's it made out of? And basically what my theory says, what my framework says, is that everything is consciousness. Everything starts as a non-dimensional space. And from that building block, everything is created. So my framework actually, it manifests the entirety of quantum mechanics out of a really simple set of equations. Basically, everything starts from singularity. Singularity then evolves into a trinity. And it's this trinity that's the fundamental resonant structure that manifests all of reality, right? Because in order for you to have resonance, you need three elements. You need and that structure is fundamental to the universe. We see this trinity everywhere, right? It like you can't not look somewhere and see it. Yeah.
Why do you need three things for resonance? I've never heard that before.
So in order
Clarify, what are the
for
three things?
synchronization.
Hold on, what's that?
What are the three things?
Yeah, clarify.
Yeah, what are the three things, and why do you need three things for resonance?
Why do you need three things for resonance? In order for the wave to propagate back to mirror off of itself, it needs three elements, I guess. You need a trinity structure in order to have a resonant structure, essentially.
Yeah, what is that trinity in this case? Megan wants to know. I want to know. Chris wants to know. Nastia wants to know.
It would be the fundamental division of unity. So it would be essentially the impulse for pushing, the impulse for pulling, and the center point in the middle. Essentially, that might be kind of the
balance.
One way of looking at kind of the initial split in consciousness.
Okay, so if you have a sine wave, you have the maximum, you have the minimum, and then you have the 0 point.
Right.
Okay.
Exactly.
And so so when you're saying that that's necessary for resonance, we can also turn it on its head and say that that's kind of some fundamental axiomatic feature of resonance.
Yes.
Like you can't, because we assume that resonance is waves, right?
Frequency is really like waves piling up in one frequency region versus another. It's like overlapping waves that construct, right?
So it's like, can we say maximum, minimum, and center?
Yeah,
okay.
that works. I like that.
Okay.
I like that because it doesn't really have any other connotations other than I think it's valid to start with essentially that kind of a conceptual play of opposites in essence, right? Because I think ultimately I think that reality is starts from that the place of consciousness of that non-physical place.
Can you make that case for us? Because
I can.
Let me
make a really strong case for this.
Can I give some background first?
Yeah.
Okay, so something that we've come across a lot is that people try to build theories of nature.
Mm-hmm.
And there's kind of like three schools of thought. There's the simulationists, that nothing really exists and it's all an illusion. There's the physicalists, where they're like everything is built out of physical objects. Jay, know that I'm also talking to you, but I can't turn my head 180 degrees. And then there's I guess like ephemeralists, where everything is kind of built out of consciousness, awareness, mind stuff. And I've always been very skeptical of any theory that comes down to one of three options. I'm kind of like, let's toss aside simulationism, because I think simulationism is a deeply disempowering philosophy, and I think that there's not really good proof for it. So let's toss that aside.
Stick to the rockets, Musk.
And so we're left with materialism and ephemeralism. Is it fair to call it ephemeral?
I mean, I guess you could call it ephemeral. I mean, to me, consciousness seems pretty fundamental. It
doesn't mean that it's not fundamental. It's just that it's not material. And if we take material to be the substantive.
Let me give you an example. Let me just tell you how I got here, because to me, it's the crux of it all. And essentially, I got here by making a prediction after making a hypothesis. And my hypothesis was this: quantum observers and subjective observers are equivalent. They're equivalent because both of them perform the same transformation on reality. They do the same thing. They look out in their environment, they sample their environment, they take a probability space and they turn it into a determined observation, right? Like that's the nature of observation. And so if that's the nature of observation, then, and if subjective observers are equivalent to physical observers, there must be something in subjective space which looks like an atom, which looks like the type of thing that we see as observers looking out.
Okay.
And so I went looking for those atoms. I went looking for the conceptual version of physical atoms, and I found them in prime numbers.
Right.
Prime numbers mean the same thing everywhere you look. Everywhere you go, a prime is a prime, and there's no hidden description of a prime number, right? And that's fundamental. And when I looked at their distribution, what I found is that I found a quantum spectral distribution. Prime numbers in their distribution encode quantum mechanics. I mean, you see the GUE in the spectrum of prime numbers. So that told me that, well, wait a minute. If I'm looking at prime numbers and I'm seeing essentially what is a quantum pattern, what does that actually mean? Does that mean that prime numbers are more than are prime numbers when I'm not looking at them? What are they made out of? Can I look at prime numbers in a different way? And it turns out that you can look at all numbers in a different way as a superposition of the prime factors that create them, right? Stop right there.
What's the,
And
you
so-
said the GUE. What is the GUE?
Gaussian unitary ensemble. It's basically a quantum mechanical structure of stuff. I mean, I don't know. It's
Hey, all right, Chris Rainey, does this make any sense to you at all?
Megan's chopping at the bit back there.
Let's end it.
Megan's on.
You got any thoughts? Does this make any sense to you?
I mean, I'm kind of gathering it. I mean, I get the idea of when we were explaining the sine wave about like positive, like a neutral and a negative, like there being three as a trinity. I got that. That makes sense.
All right, Sebastian,
Cool.
your job is to make
on my regular computer, right? So I've got the mathematics that came out of this allow me to perform quantum-like computations on my regular computer. Like I can do stuff here that you cannot normally do on a regular PC because I'm using prime numbers as eigenstates, like as actual basis states in quantum computation. And so using them that way, when you actually do the math, essentially the phase combinations of prime numbers result in what is essentially quantum-like computation. It's equivalent to physical quantum systems.
All right, Sebastian, this is we're gonna have to bring you back again to unpack this some more because there's too much to talk about. I want you to make sure that my friend Chris Rainey, who repairs machines for a living, can understand what the hell you're talking about. So I'm convinced that you understand something special and interesting about the universe, but you have to make it clear to my friends here who are not scientists. And
Absolutely.
I would love to see you work on that. So I would love to get you back here, and I want you to open up with a sentence or two that even my friend, the machine repair man, who is not a quantum physicist, can follow. That is my wish for you. And with that, I think that we should close down this episode of Paradigm Drift, my friends. And Sebastian, thank you so much for joining us. Guys, can you give Sebastian a good warm round of applause? Congratulations, Sebastian. Thank you so much, man, for coming by. Hey, you're going to be in Portugal, right?
Absolutely.
All right,
absolutely.
hell yeah.
We're all hermeticists, by the way. It seems like everyone here pretty much hides their hermetic beliefs.
You should make that your paradigm drift presentation. I want to hear this.
Yeah, I'm in good company with that.
All right, excellent. Sebastian, thank you so much. We'll see you in Portugal. We'll see you at the patron chat. Good night. Good luck.
Good night, everybody. Thank you so much. All right, they want a major ending. Let's give them a D. D major. Good night, everybody. We'll see you in Portugal. Everybody.
Thank you, Chris. Thank you, Megan. Thank you, Jay.
Peace out. Good night, everybody.